Hello, my name is ZHONG, and I'm going to present, present the power system potential project, and I'm going to introduce our member, which is we are come from section 2, group 3, and our member have Muhammad Arif being Hadi, Muhammad Faizul Hadi being Zulkifli, Muhammad Faiz Farhan being ROHAIDZAM, and me being ZHONG. Hello, my name is Hao. So I'm going to start our group project through the introduction. I'm going to introduce our project. So what is the purpose we do this project and what is the task we have to achieve and how we do the simulation. So in the modern electrical networks, especially the low voltage 400 volts distribution systems, ensuring system stability and equipment safely under fault condition is crucial. This project focuses on simulating a balanced three-phase to ground fault, the most severe type of electrical fault using a MATLAB simulator. So we do the simulation through a MATLAB simulator by modeling the fault and integrating an inverse different minimum time (IDMT) of the current relay. We evaluated how the protection system respond dynamically to extreme conditions. This study not only highlights the importance of fault analytics in designing robust protection schemes, but also emphasizes the effectiveness of simulations tools in predicting and improving system resilience.
Assalamualaikum, my name is Muhammad Faidz Farhan ROHAIDZAM and my metric number is DE220084. So now I want to explain about the literature review. First is faults in power system. In power system, faults are abnormal condition like short circuit that disrupt normal current and voltage. These faults can be either balanced or unbalanced. In this project, we focus on balanced faults, also known as three-phase faults. This type involves all three phase equally and is considered the most severe due to the high current generated. Okay, next is relevance of balance fault. We choose to simulate a balance fault because it represents the worst case scenario in terms of fault current. It's useful for designing and testing protection systems such as relays and breakers. Unlike unbalanced faults, balanced fault only require positive sequence analysis, which makes the modeling process simpler and more efficient, especially in simulation tools like Simulink. And lastly, about literature review is application in distribution system. A third more common in transmission networks, balanced fault analysis is very useful in distribution systems as well. It helps engineers determine maximum fault current, ensure proper relay coordination, and test system response under critical conditions. Using MATLAB Simulink, we model the fault and study how protection device respond, making sure the system remains stable and safe. Thank you. We go to the next presenter.
Alright, my name is Muhammad Faizul Hadi bin ZULKIFLI. So now we're going to discuss methodology. Alright, now we're going to continue with the overview of the simulation stages. So as we can see on the right side, there's a flowchart, which is firstly we're going to discuss a model 400 volt 50 hertz three-phase distribution system, and then in simulating, and then we simulate the balance fault condition, which the one we choose, and then we implement the IDMT protection as a protection device. So we can discuss it a little bit briefly into after this into three stages, which is uh, before fault, which is normal operation of the power system distribution system, and then during fault, and then with protection scheme. So now, as for the normal operation, we just build a 400 volt, 50 hertz three phase distribution system. So as we can see there, there's the normal one without fault implemented. So we use this as a standard to establish a steady state condition as a reference to for our fault analysis. And then it's just include just the basic component, as we can see there, just three phase source, distribution lines, and we add a balance load. So as for this one, we're going to discuss when we implement the fault. So it's the same as the one in the normal operation, but the difference is we add the fault at the load end. So we introduce the fault with a ground, a face to ground fault, which is according to our project, which is we choose a balance fault, and we set at 0.2 seconds. So resistance, fault resistance is set at 0.4 ohms. We would just want to simulate a realistic short circuit condition, and then this, of course, the purpose of the circuit is to evaluate the system behavior during the symmetrical fault, uh, in the absence of protection scheme. All right, now we're going to simulate the power distribution system with protection scheme. So as we can see there, we already introduced the IDMT OC relay and also an AC circuit breaker. So the relay, which is the IDMT OC relay, is configured at 5 ampere pickup current and also time multiplier settings at 0.1, which is configured as a normal inverse curve. So theoretically, this will trip signal activates the circuit breaker to isolate the faulted section automatically during the fault, which is we set at 0.2 seconds. So this is with the protection scheme.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqmal Arif. So I'm going to present about our simulation. So this is the circuit model that we have built. So this is before the overcurrent relay is added to the system. So we have a 400 volt source feeder here, and this is the 10 kilowatt load in the system, and this is scope here to measure the voltage and also the current of the system. So this is before fault. So if I run this system for 1 second, so you can see here the plot of the voltage here and also current. So this plot shows the stable waveform, stable plot of the voltage and current without the fault. Okay, so now I'm adding a three-phase fault into the system. So this is a balance fault between the three phases. So the fault is occurring at 0.2 seconds. So if I run the simulation, you can see here the plot that generated are now different from the original plot. So you can see here there are voltage drop here at 0.2 seconds, and also a high current spike after the fault occurred. So this is the effect of the fault that introduced into the system. So this is circuit after we added the overcurrent relay and circuit breaker into the system. So here is the IDMT overcurrent relay and the AC circuit breaker. So this is the circuit breaker is controlled by the overcurrent relay that will send trip signal into the circuit breaker. So the OC relay is monitoring the current from this bus, and the setting here is the low setting is 5, the TMS is 0.1, and high setting 2 times of the low setting. So this OC relay is working on CT with 5 to 100 ratio. So if we run the simulation, so we can see here the OC relay trip with 0.04 second, and the OC relay detected 519.7 M current that is uh, converted from the 25.98 M detected by the CT. So this is the plot for the system. So you can see here the fault occur at 0.2 second, and after some time circuit the current and voltage turn to zero. This is the result of the circuit opened by the circuit breaker. So for discussion, firstly we have our symmetrical fault characteristic, which is the three phase involve the three phase equally, and it is one of the most severe fault that leading high instability and also equipment damage. So secondly, the pre-fault condition, having a stable operation and balanced voltage and also the current, um, being the baseline for our comparison for the simulation. So the fault impact is immediately surge of fault current due to the reduced system impedance and also significant voltage drop. So after the simulation, we have added the protection mechanism that we choose, the overcurrent relay. So this overcurrent relay detect abnormal current level and isolate the faulted section. So the other section can return to the normal post-isolation condition and protecting the rest of the system. So the relay also need to be set. Um, the setting needs to be adjusted. So one of the setting is the time delay. So time delay is critical to operate to make sure the relay operate fast enough to prevent damage and also avoid lesson strapping. And the simulation shows the affecting relay operation. Um, so we need to validate the protection scheme that we have choose, and it is essential to manage the severe fault like symmetrical fault and ensure minimal disruption and prevent cascading failure and also maintain the service continuity.
And lastly, as a conclusion, our project is successfully demonstrate how the balanced reverse fault can be modeled, analyzed, and mitigated in a 400-volt distribution system. So these implementations of the IDMT relay with well-calculated settings ensure a fault was detected and isolated promptly. So to preventing the system-wide failure. Simulations results prove the importance of time-coordinated protection schemes and showcase how tools like MATLAB Simulink can be used for safe and detailed analysis. Ultimately, these projects enhance our understanding of power system protection and reinforce the critical role of balanced fault analysis in designing reliable electrical network. And we will make it to a short form. And we are already successfully modeled the 400 distribution system with balanced three-phase fault, IDMT overcurrent relay activity detect and isolated the fault. The relay setting 5A pickup in S0.1 ensure quick and selective clipping. Management provide a safe and efficiency simulation development and convert the importance of protection coordination in four scenarios. Prove the team's technical skill in protection design and system stability. So that's all for our group project. Thank you.